Hello everyone. This is lecture 4 and this lecture is about instrumentation and process control of fermenter. Okay, so why the controlling the process is important, because it is required to optimize productivity and product yield and ensure reproducibility of the product. Okay, and the parameters which will be controlled in a fermenter depends on the bioreactor, its mode of operation, and microorganism being used. That which means the biocatalyst which uh, is used in the bioreactor. Okay, and this table, it shows the parameters of a bioreactor which we need to control. Okay, and we can categorize these parameters into physical and chemical parameters. And physical parameters are like temperature, pressure, agitator shaft power, RPM, foam, weight, flow rate. And the chemical parameters are pH, redox, oxygen, exit gas analysis, medium analysis, etc. Okay, and so these are the parameters, or we can say that these are the variables which we need to monitor during the fermentation. Okay, and if there is any aberration, any difference from the standard value of these variables, then they need to be controlled. Okay, so and usually in the fermenter there are different control systems to control these different variables. For example, to I mean and so for example, temperature. Okay, so if there is any change in the temperature, so that need to be controlled. How that can be controlled? By using heating or cooling system. Okay, okay, sorry, I forgot to mention one thing, that these variables, the fermenters, they contain several sensors to sense these variables, to sense the values of these variables. Okay, okay, and as I just said, that there are control system to control if the value of these variables are different from the standard value. Okay, so we'll talk about this in more details in later slides. So, and this photo is it's just show a cartoon photo of several instruments that a fermenter have. Actually, this photo don't contain all the instruments. It's just show some of the instruments, such as, for example, there is foam control system, pH control system. Okay, control system to control the speed of the rotator. Okay, which steer the fermentation media. Okay, etc. So we already know that there are different sensors to sense the or measure the value of different parameters. Okay, and these sensors can be classified into three main classes. Number one, sensors which penetrate into the interior of the fermenter. For example, pH electrodes, dissolved oxygen electrodes. Then sensors which operate on samples which are continuously withdrawn from the fermenter. For example, exhaust gas analyzers. And then the last type of sensors which do not come into contact with the fermentation broth. Okay, so these are the three main classes of sensors that are used in a fermenter. Anyway, depending on the application, the sensors, they can be classified in different way, such as inline, online, and offline sensors. Okay, so this classification is based on their application. So how we use the sensors in a fermenter. So among this, the inline sensors, they are an integral part of fermentation equipment. Okay, and the measured value by this kind of sensors can directly obtained from it and can be directly used for process control. Okay, and in case of online sensors, they are also an integral part of fermentation equipment, and the measured value cannot be used directly for control, and that means another operator must enter the measured values into the control system for subsequent process control. From the sensor, the sensors will show the value, then an operator have to measure this value and calculate that what kind of correction or control need to be applied in the process control. In case of offline sensors are not a part of, not an integral part of fermentation equipment, and the measured value cannot be used directly for control. And again, an operator is needed for actual measurement and for entering the measured value into the control system for process control. Okay. Okay, so this was about sensors. Now I'll talk about process control. I mean, uh, process control. Control of different processes of the fermentation. So the pH, the pH of can be maintained at the desired value by their automatic addition of acid or alkaline in response to changes recorded by the pH electrode, that is pH sensor. Okay, and temperature is monitored via resistance thermometers and thermistors linked to automatic heating or cooling systems, and levels of dissolved oxygen and carbon dioxide are determined using oxygen and carbon dioxide electrodes, and foam is controlled through three basic methods: media modification, mechanical foam breaking devices, or the automatic addition of chemical anti-foam agents. Okay. Now the temperature control. Okay, so usually the most fermenters are operated around 30 to 36 degrees Celsius, and for cooling, water jackets or pipe coils are used. In case of large fermenters, a regulatory valve at the cooling water inlet may be sufficient to control the temperature. Okay, and there may be provision for circulation of refrigerated brine if excessive cooling is required. So usually in the fermenter, cooling system is done by water. Okay, so water is used as coolant there, but sometimes if the fermenter they if particular fermentation process produce excessive heat, in that case only water is not enough to cool the fermenter. Okay, so in that case refrigerated brines can be used. Okay, refrigerated brines, they are more efficient coolant than water. Okay, then flow measurement and control. Okay, so in fermenter, flow of different parameters need to be measured. Flow of gas, flow of liquid. Okay, so for gas, the most commonly used example is rotameter. Okay, so rotameter, they are one type of meter which we can use to measure the flow rate of gas. Okay, and the rotameter consists of vertical glass tubes and free moving float, and the position of the glass tube is indicative of flow rate. The same rotometers, rotometers can also be used to measure liquid flow rate. That means rotometers can be used for both gas and liquid. Okay, so if you google, you will, if you just type rotometer in google, you will find several photos there. So these are example photo of rotometer. Okay, so the vertical glass tube and inside the uh, free moving float. Okay, liquids. So for liquid flow measurement and control, electrical flow transducer can be used. Rotometer can also be used. Okay, but usually electrical flow transducer are used. Okay, so and electrical flow transducer can cope with particulate matter, so all the particles which are which the liquid contain. Okay, so it can measure a flow rate from very low to high. It's the benefit of electrical flow transducer, that they can measure the flow rate from very low to high value, like 50 cubic centimeter per minute to 50 500,000 dmq per minute. Okay, so the range is very high. Okay, then pressure measurement. And pressure measurement are needed for several reasons. One, safety. Another, media sterilization. So safety, it's easy to understand, right? If too much pressure is built up in the inside the fermenter, it can even blast. Okay, so like a bomb. So safety, so for safety issue, pressure measurement and controlling system is necessary. And another purpose is for media sterilization, because I mean, say if you are doing in situ sterilization of the media, that means you will, okay, so in that case, we know that only temperature is not enough to ensure proper sterilization, because the effect of sterilization comes from the temperature and also the proper adequate pressure. Okay, and for measuring the pressure, there are gauges or meters to measure the pressure. For example, bourdon tube pressure gauge, they are actually pressure meter by which pressure can be measured. Okay, and usually in the pressure control system there are safety valves. Okay, so safety valves should be incorporated at various suitable places in all vessels. Okay, and the valve should set to release the pressure as soon as it increase above normal level. I mean, there is pressure gauge, it's continuously measuring the pressure. So if the pressure goes above the normal level, then these valves, they can be opened. Okay, so usually, I mean, you can do it manually, or usually in the modern fermentation process they're kind of automated. Okay, so whenever the pressure goes above the normal level, this valve, they get released and pressure is released. Okay, then power and rotation measurement. uh, Agitation shaft power. Okay, so the to measure the power consumption by a fermenter. Okay, so how much power a fermenter is consuming. Okay, so I mean, most of the power is actually consumed by the shaft rotator. Okay, so it's important to measure its power consumption and rate of steering. Okay, so it is important to monitor the rate or rotation of the stirrer time. Okay, we know why it's important, because rotation is a very important part of the fermentation, because it's ensured the proper mixing. Okay, it's ensured the proper mass transfer. Okay, and also it's ensured the proper shear force. So if the rotator it moves too fast, okay, it will cause more shear forces, which will may hamper the microorganisms. Okay, or even I mean, if it rotates too fast, I mean, it can interfere with the proper mass transfer. Okay, and the rotator speed or stirrer speed, they are measured by tachometer. Okay, so now the foam controlling system. So I mean, in most in the fermenters where foaming is a problem, foam control is a must actually. So how the foam control system works, this is the step by step process, and the same process is depicted by this diameter. Okay, so say this is the fermenter. So there are probes are used to measure the foam. Okay, and these probes, okay, uh, in the foam there are electrolyte. Okay, so this probe, I mean the foam detector probe, they can detect the electrolytes of the foam. Okay, so if the electrode, I mean the foam detector electrode, they can detect the electrolytes of the foam, they will generate a signal and pass the signal to a detector. Okay, so then this detector, they will analyze, I mean actually there is a computer. Okay, so that computer will analyze that, okay, there is foam, and then it will analyze that how much anti-foam need to be need to be put in the fermenter. Okay, so this computer, they will analyze the amount of antifoam that will be mixed into the fermenter, and for how long. Okay, so actually, you know, they will select two things: one, how much antifoam will be mixed into the fermenter, and for how long. Okay, so setting timer is actually important here. Okay, so I mean, whenever the probe detect the antifoam, you just cannot I mean continuously add antifoam into the fermenter. Okay, because antifoam is a chemical. Okay, so you, when after the antifoam is in the fermenter, some time is required to, I mean, the foam will mix with the antifoam, then it will work, right? So the detector system, they also analyze this. Okay, so so okay, I'll tell again. So the probe, it will detect the presence of the foam and it will send the signal to the detector. The detector will then set the timer and amount of antifoam that is that will be mixed with the fermenter, and there is a pump. Okay, this pump will control the mixing rate of antifoam. Okay, so this is how the foam control system works in a fermenter. Okay, then measurement of microbial biomass. Okay, so estimation of microbial biomass is an obvious requirement. Okay, so and there are different methods by which it can be monitored. I mean, the amount of microbial biomass can be measured and monitored. One way is by measuring dry weight samples, that means the dry weight of the samples, or by electrophotometers. By electrophotometers, cell density is measured, and from that we can gauge the amount or number of biomass. Okay, or we can directly count the cell numbers by using Coulter counters, or fluorescence measurement can be all is can also be used to measure microbial biomass. Okay, so that's all for this part. In the next part of this in the next part we'll learn about some other sensors and their control system. So thank you.